Okay, folks, what we're looking at here is some function notation work. If I have f of x equals some expression on this side here, for argument's sake, let's say x squared plus 2x plus 3, or plus 1. If I see a situation where I have f of x plus h, or f of g, or f of a cow, basically what it means is, you go back to the original function f of x, and wherever up here you see an x, so you've got an x there and there and there, wherever you see x on this right hand side here, you have to replace it with whatever is in the bracket. Once you've replaced it in the bracket, just a direct substitution, and for the first step that's all you do, then what you have to do is you have to expand it and simplify it so you reduce it back to a simple polynomial. So in this case, what we end up with, we'll do the x plus h one because that's the same as the one in this item. If I go f of x plus h, what I end up with, everywhere I see x, I write x plus h. So that becomes x plus h squared plus 2 brackets x plus h plus 1. Notice it's exactly the same expression, except wherever I see x, I write x plus h. If there'd been a term in front of the x squared, like 3 or whatever it might have been, you would have a 3 there. Then what you do, as I said earlier, is you now take this right-hand side and you simplify it, get rid of the brackets, and turn it back into a nice, as simple a statement as possible. Now in that, we'll do it with the 3. In that first term, you do the brackets first because that's order convention, so I have to square x plus h. So it's x plus h by x plus h, and if I work that out, that's x squared plus 2xh plus h squared. Now you can do that in a couple of steps if you choose to. Plus 2x plus 2h plus 1. Now having done that, we then continue our simplification, taking the 3 and distributing it across the whole bracket, plus 3h squared plus 2x plus 2h plus 1 equals and so on, and eventually you will get that to a nice simple polynomial, combinations of, in this case, x squareds, xh, h squareds, and numbers. Now, one of the things you have to be particularly wary of, and it occurs in this item, if the original function had not been 3x squared plus 2x plus 1, where everything's nice and positive, if it had been something like 3x squared minus 2x plus 1, this minus here can cause a sign challenge. Now, let's do the x plus h substitution again. Minus 2x plus h plus 1 equals, that part there is fine, that's all positive, and it continues on exactly the way it did up here. I'm interested in this one here, this term. Notice at the moment we've got a minus 2 out the front of the bracket. What that means is that everything in the bracket has to be multiplied by minus 2, not plus 2. So when I put the 2 with the x, I would get minus 2x. But then when I put that with that, it becomes, because it's minus 2 at the front, it becomes minus 2h. Now that sign there is a minus. Often when people do these things and they've got minuses in them, that's where errors arise, because what they do when they expand their bracket is that they forget when there's a minus at the front here, you have to put that across every term in the bracket. And that's essentially the way these function things work. The process, irrespective of what you put in the bracket, whether it's x plus h or a cow or whatever, the process works exactly the same way. You just take whatever's in that bracket, and on the right-hand side, wherever you see x, you replace it with what is in the bracket, and then you just multiply it out and simplify it out to get it back to a nice simple something plus something plus something minus something or whatever.